working with the current project, then so you got a requirement in the Snowflake, then you have jumped into Snowflake, like that you can mention.
Hello.
Hello.
Yeah, sir. Now it's audible.
You got your answer?
Yes, sir. Thanks.
Okay. Srinivas, you are working as a Oracle developer, right?
Yes, sir. You're right.
You have 10 years of experience.
Yes, sir.
Other than Oracle, any other database, any other technology?
No, sir. They said Oracle Forms I'm working.
Oracle Forms, nothing but reporting to.
No, only Forms, not reporting.
Okay.
D2KBC, right?
Okay. Yeah, let's start the discussion now. Anyone has any queries on previous class, previous yesterday session?
We have discussed we can write query like in Oracle or in SQL Server, correct?
No. You complete your question.
Yes, my question is
Ratan.
like that. Suppose I'm writing NoSQL concept, okay? So
Okay.
how it will work in SQL statement? Like it will work?
In Snowflake,
Yes.
see, whatever the data loaded into a Snowflake, that will be stored into the tables, right, Rajiv? That is
Yes.
clear.
Yes.
Either a structured data, either semi-structured data, either blob data, whatever. Finally, the data will be loaded into the table. Table nothing but a combination of columns and rows, right?
Right.
While retrieving a data, then you are using a SQL to see the data, to retrieve the data. I told yesterday, this Snowflake is compatible with all the RDBMS SQL syntax.
Okay. But I have one question here, like how this JSON data will store in table.
Yeah, JSON data is a semi-structured data. While loading a data itself into a Snowflake table, so we have some techniques, we have some concepts in Snowflake. We will apply those and then load the data into table, or you can load entire whatever we have a raw data in JSON, load into the table, into your Snowflake table, while extracting a data from a Snowflake table, then you can write some SQL code to get the data into a correct format. Clear?
Okay.
Then we will see
Yes.
that as part of this course, we have a very good concept loading the data, semi-structured data into Snowflake, and then work with the semi-structured data.
Okay. Okay. Thank you.
Clear?
Clear. Yes. Thank you.
Okay. Then can anyone let me know any idea? One second. Any idea how? So I'm not talking about a Snowflake or any other particular database. I am speaking general database. How the data is going to store in the database. Just I'm not talking about a particular Snowflake or any other Oracle or Teradata or SQL Server. Just I am asking, what is the structure if we load the data into a database? Any idea?
Like it's stored in the form of rows and columns, right?
That is okay. That is fine. Obviously, when we load the data into a database, the data will be stored into the database tables. On a table will be having the columns and then rows format. So that is a very basic concept. I am asking some internal things.
Oh, okay.
Okay, let's I am discussing now how the data will be going to store in a traditional database. To overcome that, what the Snowflake has implemented, so that we will get the very good knowledge on how the data is going to store. Fine. See, let's consider when the data is loaded. I am talking about now traditional database storage. Traditional database storage. Fine. When we load the data into a when we load the data, let me open Excel sheet. That's fine. Actually, I have a problem with Microsoft Office with my laptop. So there is a problem. I'm not getting why, I don't know. See, fine. See, we are talking about a database storage. See, when we load the data into a database, directly we'll store the data into initially data files, right? Data files, nothing but this is hard disk. There will be multiple drives. You just stop me if you feel I am little bit slow. What I am telling, when you store your data into a database, the data will be initially the physical data will be stored into a directly into your data files. Data files will be stored into a hard disk. This hard disk nothing but the database files will be configured into your hard disk file. So there so they will divide your data into a multiple data files. These data files will be stored into the multiple drives. Fine, this is clear. And then while working with the traditional database, there are many things are involved here. So this is about a storage. This is about a storage. What about the process? There are many things involved: CPUs, memory, and network infrastructure. Network infrastructure, servers. While reading a data from any traditional database, I can say the storage is 1 point, and then this process is 2 point. While reading a data from the database in your traditional database, these many things are involved. These many things will be utilized, and then your data will be retrieved from the database. Fine, clear, or you are getting any confusion here? If you understand this, then it will be why I am saying there is a beautiful concept in our Snowflake. There is a difference between the traditional database and the Snowflake database, the data storage. So that I am explaining the traditional database, so that if you thoroughly understand this, then it will be easy to understand the next level. Any doubts in this, are you clear? Okay, I will take silence as acceptance. Fine. So in this case, this is about our traditional database. Coming to Snowflake data storage. Coming to data storage. Separated the storage and compute. I can say this is the compute. This is the compute. Fine. What is the advantage here? Separation of the storage and then compute in Snowflake. See, when you load your data into Snowflake, data will be stored in cloud. Fine. There is no dependency between the storage and then compute. Both will work individually. So you can ask me, what is the compute? Compute will help to execute the SQL queries by allocating the hardware resources. See here, what I'm trying to explain here. This storage will take care of the data storage in the cloud in Snowflake. This compute will take care to execute your SQL queries while communicating with the database in Snowflake. Here, the storage and then compute both are separated components here. So there is no dependency between storage and then compute components. In case of our traditional database, while working with, if you hit any SQL in your database, all these things will be, there is a dependency between the one component to another here. So to overcome this, they have implemented this very good architecture, and then they have separated the storage and then compute. So you can ask me, so what is the advantages? What is the advantages over separating the storage and then compute? Means once you execute a query into your database, it will give you a very good performance while retrieving a data from the Snowflakes. That is one of the major advantage thing actually. So this is very high level knowledge on storage and then compute of the Snowflake. Clear on this, or anyone has the doubts? Hello. You are able to hear me?
Yes, yes.
Yes, yes.
Yeah. Clear, right?
Yeah,
So
okay.
we will discuss about Snowflake architecture. Snowflake architecture has the multiple layers. Let me show you here. Yeah. So this is a Snowflake architecture, and so by these layers only the Snowflake will be work actually. The very first layer is data base storage, where we are going to store a data in your Snowflake, and then query processing. This is virtual warehouse. We will going to see what is a virtual warehouse, what is query processing. The collection of a multiple virtual warehouses is a query processing layer, and then third one is uh, cloud services layer. This cloud services layer will have the authentication, and then infrastructure manager, and then optimizer, and then metadata manager, and then security. So these three layers are very important in the Snowflake. These three layers are going to play very key role in the Snowflake while dealing with your business data into your Snowflake. Fine. Then we'll see one by one what is the functionality of each layer in the Snowflake. First one is data storage. So here, when the data is loaded into Snowflake, it is reorganized into multiple micro partitions that are internally optimized, compressed, and stored in columnar format. Fine. When data is loaded, when data loaded into a Snowflake, the data will be stored in a micro partitions. I will tell you what is micro partitions. Micro partitions internally data will be optimized, compressed, stored in columnar format. Any idea what is the meaning of this columnar format? Do you have anyone has the idea what is this columnar format?
Like usually the data will be stored in row format something. Like nowadays
Okay.
it is storing in the column itself for faster access something performance related I heard. Not exactly.
Okay. Yeah, I will show you what is the columnar format, and then I will explain it.
Okay.
Fine. Very first layer is data storage layer in architecture, Snowflake architecture. When the data is loaded into a Snowflake, the data will be stored into a micro partitions. This is a very key component in our storage layer. I will explain later what is micro partitions. And then when the data is stored into the micro partition, this Snowflake itself will take care that the data will be very optimized and then compressed. What is the meaning of this compressed? Actually, suppose if we have a, let's example around example I'm giving, we have around 10 MB of data in your original source. While loading the data into a Snowflake, it will compress the 10 MB and then it will make it as around 6 MB or 7 MB. Such algorithms will be applied onto your existing data, and then data will be stored into your compressed manner. Then you can ask me what is the benefit? What is the benefit? What is the benefit to compress and to store the data into Snowflake. So if you store the data with a compressed manner, the storage location will be occupied less than what is the original data you have. So based on that, the pricing and then billing will be happen. So how much data you are going to store in your database or data warehouse, and then so based on that they will charge to pay the amount to the Snowflake service provider. So if you have a 10 GB of original data, after compression of your data into a Snowflake, maybe it will store as 7 GB. Then you are going to pay only 7 amount for the 7 GB. So that is one of the major advantage here, compressed. And then this Colmer format. Colmer format nothing but data in our traditional database. Data will be stored into a like column. Data will be stored in our rows into columns. Column 1, column 2, column 3. 1, 2, 3. Data 1, data 2, data 3, data 1, data 2, data 3. So this is our traditional database data storage in a table. In case of our Snowflake, the data will be stored in a columnar format. This is a diagram of your columnar format. When the data will be stored into a database in a Snowflake, so this is a example of your table data. The columns, the table has a column type and then name and then country and then date. So this is our, as usual, traditional data. When the data will be loaded into your Snowflake, the data will be stored into a micro partitions. This is the structure of the micro partition. When the data is loaded into micro partition, the data will be stored in like a columnar format. See here, the type and then name and then country and then date. So that will be, so first row is 2, fine, second row is 4, or else first row is 2 and then A and then UK and then 112. So this is the columnar format. So we will see what is why they are going to store a data in columnar format. Then we will discuss further advantage of that columnar format. Next, when the data
sorry.
is loaded, yeah.
Sorry, it's like now they're converting a row into columns, sir. This is what the column format you want to say?
No, not in a converting into rows into format, not in a converting rows into format. The architecture itself they have built in a Snowflake. When you load your data, suppose you have a data like columns and then rows, that data is loaded into a Snowflake. The automatically Snowflake will store the data into columnar format, not like your traditional database structure. The data itself it will store into a this format internally that we can't see.
Okay.
Internally the direct see, in traditional databases we have a concept called data pages. In the data file itself, I discussed about this data files, right? We discussed about data files. In this data files itself, again we have a internally concept called extents. The data will be divided into extents. Within the extents, we have a data pages. Fine. The core data store component in a traditional database will be in the data pages. The collection of number of data pages will be extents. Even in extent, so maybe it may be causing the little bit confusion. Just I am discussing to difference between the both the things. Fine. Like that, when you store your data into leave about the traditional database, when you store your data into your Snowflake, the data will be stored in initially micro partitions. These are the micro partitions. So the data will be stored into a columnar format. So in the clear. Automatically, it will take care. We are not going to store in a column format. The Snowflake itself, the architecture they have designed to store your data into this column format. Why they are storing this column format? We have a very good advantage while storing a data into a column format that we will be discussed as part of after this architecture. You are clear? I don't know who asked the query.
Yes, sir. Yes, sir.
May I know your name, please?
Srinivas.
Srinivas. Okay, you are clear, right?
Yes, sir. Thank you.
Yeah. Fine. Where? See, we were discussing. Yeah. When the data objects are stored in the data objects are stored in Snowflake, the objects are stored in Snowflake, we can't see or we are customers. Data directly can use SQL to read the data from Snowflake. This is applied security. Leave it. See, when you store your data, into your Snowflake, then anyone, either you or a customer, can't able to see the data from the Snowflake directly. If you want to see the data from the Snowflake, you can use SQL command. To read the data. Fine. Next, by applying all these things, terminologies or technologies, by applying this optimized and then compressed and then calmer format, so you will get the faster result from the SQL queries. Fine. So this is about data storage architectures, data storage layer in the Snowflake. The very basic thing is the data will be stored in a micro partitions. Once the data is going to store in the micro partitions, it will be very optimized and then compressed and then stored in a column format. Fine. So compressed, why this is compressed means you are going to pay how much the space has occupied in the Snowflake. You are not going to store, suppose you are going to load 2 TB of data into Teradata, then it will compress and then it will store into a Snowflake, then you are going to pay that much amount, not for your entire source data. So that is the advantage. Next, what is micro partitions? Then that we are going to discuss after this architecture. And then once we store your data into a Snowflake, we can't or anyone can able to see the data from Snowflake directly, so that we can use SQL query to see the data in the Snowflake. And then by applying all these things optimized and then compressed and then calmer format, then we will see the very good performance while executing SQL queries. So this is about storage layer. Clear, or anyone has doubt on this? Query processing, next layer. Yeah, this is query processing. What is this query processing? What it will do? Basic functionality of this query processing is it will take care of query execution. It will take care of query execution in this layer. Fine, next. See, I told you earlier, they have separated the storage and then compute layer. So here the compute layer part will be involved here. I will explain you. While executing a queries in Snowflake, it will utilize the virtual warehouse. It will utilize the virtual warehouse. So this is the beautiful concept in our Snowflake virtual warehouse. Each virtual warehouse will perform a massive parallel processing. So each virtual warehouse independent, not depend another virtual warehouse. As a result, no impact on any other virtual warehouse, and that's fine. Then we'll discuss one by one. What is this virtual warehouse? What is this massive processing? See here, we discussed about storage. When the data is loaded into a Snowflake, the data will be stored in a cloud. That is storage layer. While to execute your SQL queries in your Snowflake, you need a support or you need a help from the like processes, network infrastructure or hardware infrastructure, right? See, as explained in your here. So these are the compute layer. This is the process. To execute your SQL queries, you need these processes are involved. So this will be taken care by this query processing layer. So here that will be called as a virtual warehouse. This virtual warehouse will have the resources like CPU, memory, and then network infrastructure. While executing a query, this virtual warehouse will be involved here, and then it will give the result to end user. So virtual warehouse is a like your queries will be executed in a parallel way, not like a one complete not like completion of one SQL query and completion of another SQL query, completion of another SQL. So it is the robust the beauty of this virtual warehouse concept is it will execute your queries in a parallel processing. So that's why we can call it as a massive parallel processing. So this virtual warehouse within your database there will be a multiple virtual warehouses. So let's explain. So little bit ambiguity here. See, I will explain you what is virtual warehouses. Why? Then only we'll come to know. See here, while executing while retrieving a data from the data warehouse, where the data will be available in the database or a schema in Snowflake, right? To retrieve the data from the Snowflake, here virtual warehouses are involved. Let me explain. Let me show you that Snowflake thing. One second. Then only we'll understand clearly. Leave it. I will explain you. This is virtual warehouse, nothing but here. See, we have a different schemas in our database, where in previous class, in yesterday's class, we have discussed like in data warehouse, the tables will be grouped into a multiple schemas, right? Multiple schemas. While retrieving a data from the multiple schemas, these virtual warehouses are involved. These virtual warehouses are the key part. It will provide a hardware resources to your SQL queries to execute and then retrieve the database. Fine. So storage is another one component, and then this compute virtual warehouse is another component to execute your SQL codes and then retrieve the data from the database. Then this virtual warehouses will be involved while executing a query. This virtual warehouse nothing but a process or a compute. So hardware resources. This virtual warehouses will be multiple virtual warehouses in your data warehouse. Just I'm searching that URL. Where is that URL? If I show that, you will get the 1 second. Stop sharing. 1 second. I will explain you. I don't know where I store that one. Yeah. You are able to see the screen, right? So this is your Snowflake web user interface. This is your Snowflake web user interface. Okay. So we are discussing about a warehouse here. So what is a virtual warehouse part here? See, when you execute your SQL query in your Snowflake, so you have a warehouse concept called here. This warehouse, this is a database, and then this is a schema where this particular table is stored. Means the table is stored in a particular schema and then particular database, and which virtual warehouse is using to retrieve the data from this database and then this schema. So here is they have decoupled or separated storage and then compute. As I discussed in the previous point, they have separated. They are going to use, suppose this is database and schema, and then this is warehouse. Let's consider we have a data for a different purpose, like business intelligence purpose, DBA purpose, and then DBAs are accessing your Snowflake. They are accessing their related tables, and then business intelligence to prepare some reports. They are accessing their data from their tables, and then data scientists, data analytics, data engineers, database developer, application developer. So instead of providing a common table to all the people, they are going to load a data into a schemas and into particular their schemas only. Nothing but for suppose for DBS, we have a couple of list of tables. The data will be loaded into their DBA related tables, and then for the application developers, we have a set of tables. The data will be loaded into separate set of tables. So while executing a DBA related queries, they will query on the DBA related tables, and then they will use the DBA related warehouse only. Nothing but DBA related hardware resources. This warehouse will be provided hardware resources to retrieve the data from the your physical storage. Fine. Suppose if a BI business intelligence developer want to access the data from the database, again he will be having the separate data, separate virtual warehouse here, and then separate database, separate schema. So he will use a separate virtual warehouse. He will use the data from the database. Like this, we can create a multiple virtual warehouses here, and then each warehouses will not be dependent on another, so that you can retrieve data from the database very fastly. I want an answer from you. Have you clear or not this virtual warehouse concept? If you don't understand this virtual warehouse concept, then it is very difficult to proceed further. Have you understand virtual warehouse concept? Fine. I will take it as a silence. So this query processing layer nothing but it's all about the virtual warehouse. When the data is executing, it will be use the virtual warehouse concept. The virtual warehouse will be like MPP, massive parallel processing. So finally, this is each virtual warehouses are independent. It will not depend upon another virtual warehouse. It will not depend upon another virtual warehouse. As a result of, there is no depend on virtual warehouse. So this is about data storage layer and then query processing layer. And the next, coming to the cloud service layer. So what it will do? Cloud service layer, it will coordinate with the Snowflake for all the operations. This is the layer. This is the layer. To coordinate with the Snowflake for all the operations. What are those operations? As we see in our architecture, like authentication, infrastructure manager, optimizer, and then metadata manager, security. What is this authentication and then access control? So whoever is going to log in into a Snowflake, whoever is going to use a Snowflake, so they will be having their accounts and their roles. Fine. So it will take care, this layer will take care of the authentication and then users and then roles part here. And then it will also take care of the infrastructure manager. Infrastructure manager nothing but like our hardware resources. Let me clear a few more points, then only we'll understand. Login requests made by users must pass through this layer. Query submission to must pass through metadata information. Fine. So this is about our cloud service layer. See, this cloud service layer is a very main layer. It will coordinate with the Snowflake for all the operations. Suppose if you log in into a Snowflake, then you need to pass through this Snowflake layer. This will communicate with the Snowflake. Hey, particular user is going to log in into this Snowflake, and then username and then password will be stored in the metadata information. Once the login is going to use the Snowflake, it will check in the metadata information. So like that, when the query is submitted to Snowflake, it will check the your syntax, and then it will check your query through the optimizer, as I discussed in the architecture, the diagram. It will check the optimizer. So likewise, whatever you store a data into your Snowflake or a storage layer, that data and then storage information will be logged into the this metadata tables, metadata tables. Nothing but how many files are loaded into Snowflake, and then how many rows are there in that, how many columns are in that file, in that particular files. So that entire information will be stored in this metadata tables. Metadata tables. So this is about our Snowflake architecture. Clear? And then we will discuss this. What is this micro partition? What is this micro partition? So micro partition, continuous storage in Snowflake. Automatically data will be stored here, automatically stored here. So this is a physical structure. This is a physical structure. Many micro partitions will be involved for the particular table. Per table, each micro partitions so micro parties will have the data with 50 MB to 500 MB. Fine. See here, when the data is stored into a Snowflake, automatically the data will be stored into a micro partitions, into a multiple micro partitions. These micro partitions will be stored in a continuous storage location, nothing but partition 1, partition 2, partition 3, partition 4, like that. So this is a physical component in your Snowflake, where the data is going to store in a Snowflake. Fine. And then so each micro partitions will be having the size around 50 MB to 500 MB, 50 MB to 500 MB. So this is about our micro partition. That's it. So this is a physical storage structure in our Snowflake, where the data is going to store. When the data is stored in the table, the data will be stored in the micro partition. So this is the core component in Snowflake. This is all about that's it. Data will be stored in the column format. Just I want to response from you all. You have any queries on this? So this is very basic concept in Snowflake. If you don't understand architecture and then this micro partition concept, then it will be, and virtual warehouse. Virtual warehouse will be discussed in detail in next class. But I need at least a thorough understanding of this Snowflake architecture and then this micro partition. Then only it will be good to proceed in next class. Can you let me know, anyone? Do you have any queries on this? Snowflake architecture or micro partition component. Then shall we discuss remaining concepts in tomorrow's class?
Okay, sir.
All are fine to have a class in tomorrow. Srinivas, Harshini, Shashikumar, Shivakumar, Sunil Kumar. No. Yes. Sunil Kumar, no. Shashikumar, yes. Sunil? Hello? You are able to hear me, or I'm not able to hear your voice. Srinivas, you are fine, right? To have a class tomorrow?
Yes, sir.
And then Harshini? Hello? Shashikumar, you are fine? Okay, let's meet tomorrow same time at 10:30. Fine. All are except Sunil Kumar has some issues to connect to tomorrow, but remaining all are agreed to have a class tomorrow. Then let's have tomorrow at 10:30. Fine. Thank you all.
Thanks, sir. Thank you so much.
Yeah, thank you all.